A lot of people have utilized MEMS technology, but using it for something like speakers and cooling is actually a very interesting approach. Can you tell us a little bit about the technology when we take a look at here?
Sure. This is xMEMS Labs. We're a Silicon Valley fabless semiconductor startup. We work on a PiezoMEMS platform that uses PiezoMEMS as basically an air mover. So we can move air for sound reproduction, or we can move air to cool things.
Well, great. Let's take a look at it.
This is a demonstration of the xMEMS microcooling technology. What we're going to show here is the back pressure characteristic of this MEMS silicon air pump. So what we do is we've got the microcooling chip here integrated in this 3D printed manifold, connected to 4 meters of plastic tubing. This is resistance. And we're going to show the power of the airflow and the back pressure. So now we've got our drive box on, and the silicon air pump will start pumping air through this tubing, and you can see the net airflow as the bubbles in this little container. So this is about 1,000 pascals of back pressure pumping air into this little water jar. This is a demonstration of the airflow of the xMEMS microcooling solution. So we've got the xMEMS microcooling chip integrated into this 3D printed manifold, connected to this manifold here, and we're going to be spinning this wheel as a way to visualize the airflow. This is basically driving the MEMS, but this prototype drive box all shrinks into a 2.5 by 2.5 millimeter WLCSP chip for really small form factor electronics. So let me get this started. We will start the airflow. It will start to blow this wheel as a way to visualize the airflow coming out of the microcooling chip. Now, airflow is reversible, just to show that. So I will actually click a button here. We will change the polarity on the MEMS, and as you saw there, the wheel stopped briefly and started to go the other direction. So we started airflow this way, and then when we reset it, we are now pulling air through the chip the other direction, bidirectional airflow.
So those are some really neat demos. And obviously cooling something like chips might be one aspect of it. Could you tell us a bit more about some of the applications that this could be used on?
Absolutely. So for the microcooling, thermal is one of the biggest challenges in electronics today. Everything is more thermal limited than MIPS limited. Mm-hmm. So we want to bring cooling, active thermal management to products that could never accommodate it before. First and foremost, the smartphone. That's passively cooled today. Mm-hmm. You can't fit a conventional fan in a smartphone, but they desperately need active cooling. So we're bringing this 1 millimeter thin active cooling chip into smartphones. Other applications, smart glasses, compute, optics, displays, lots of heat in a very small form factor, great application. Then we move into consumer and data center computing with SSDs, both consumer form factor, data center form factor, optical transceivers in data centers, voltage regulators, voltage converters, all are lower power. Not, you wouldn't put liquid cooling on these things, but they do need spot cooling for these low power electronics to perform at their capacity. Now,
you also talked about speakers. How does this technology work with respect to speakers, and are there significant advantages to it?
Yeah, absolutely. So because essentially we're a voltage controlled airflow source, we can use that airflow to reproduce sound and basically take the century-old coil and magnet speaker and shrink it down to a solid state 1 millimeter thin variant. With that, you get better part-to-part consistency, better left-right audio consistency, crystal clear audio performance in a really, really thin form factor. So as we look ahead, if we look beyond earbuds and headphones into smart glasses, smart watches, and any other AI interface we may have on or near our body, you need a small, thin speaker that just disappears into the electronics. Looks like a fashion product, not a geek tech product.
Now, put these all into context. Obviously, for the cooling, you're not going to be moving large amounts, to essentially cool this room, for example. And likewise for the speakers, you're not necessarily trying to build giant speakers. Where do these fit, and how far up and down do they scale?
Yep, correct. If we start with speaker, our technology started in earbuds, in the ear. We expanded that into over the ear, into headphones. And now with our latest product, Sycamore, which is the world's first silicon loudspeaker, we can now get what we call near field, things that are on or near the body like watches, glasses, but not necessarily in the ear. So the technology is slowly expanding further and further away from us. Next step, smartphone. Maybe a step beyond that, we get into your home entertainment center or in your car.
Okay. Now, on the cooling side, how about that? Obviously, you're not going to try to even cool an entire PC, but you can be much more focused.
Yeah, we have to do what we do best. We're small, we're tiny, the world's smallest air mover. So we're not a fan replacement. Fans are great. They do their job very well, but there are places fans can't go, and that's our opportunity. So we're not going to necessarily cool an NVIDIA GPU per se. That's not our specialty. We want to focus on lower power stuff that fans just simply can't reach or can't fit in.
Well, let's talk about those NVIDIA GPUs. A lot of them, especially on enterprise systems, are going to be liquid cooled these days. But because they're doing the liquid cooling, how does that change the design of the system? Because obviously, the air cooling that used to be there can't affect the rest of the system.
Yeah, absolutely. So as you move the high power technology like a GPU to liquid cooling, the rack server designer now has the opportunity to try to remove fan arrays to lower power, to reduce noise. But now the lower power things that were never a problem now become problems. So that's really our opportunity to balance the liquid cooling for the high power and then this really small opportunistic spot cooling for some low power things inside of a server, a PC, or a laptop.
Now, would I want to wind up putting, individual devices that you have on each of the various chips, or is there a different approach?
Yeah, so you can certainly go chip to chip with the cooling, one to one. But really the power of this air pump is it can pump air through really, really narrow ducts or channels or over long distances. So it's a tiny air mover, but if you channel the airflow correctly, you can go one to many. So create an intelligent duct, a well-designed duct, take one air cooler and channel that airflow across an array of chips on a PCB. So it's one to many.
Well, that's fascinating, and looks like it's going to be easy to incorporate. I assume the speakers, for example, can go to your regular amplifiers?
So this is PiezoMEMS, so they are driven a little bit differently than, say, a conventional Class D amplifier. So xMEMS has its own ASIC team, and we turn our own ASICs that basically abstract the complexities of driving the MEMS from the system. So we're a two-chip solution. There's a MEMS chip for the cooling or speaker, and then there's a companion ASIC that takes 3 volts in, I2C control, or a standard audio signal in to create the system. The system's none the wiser that it's dealing with a new type of technology. The ASIC hides that complexity.
Okay. How about on the cooling side? Do you have any sensors built in? For example, maybe a thermal sensor if I don't have something already built into my system?
Yes, so there's a temperature sensor capability built into the cooling chip itself as well as the ASIC. So you can set some programmable temp thresholds to determine when the fan turns on, turns off. So that's all programmable.
Okay. Now, specifically on the fan, is it as controllable as the speakers are in terms of, how much pressure you're generating and so on?
Of course, just think of it as an analog dial. So you can turn the airflow low, you can turn it high depending on the needs of the application. So it's power versus performance trade-off. But with all of this technology, these are chips. So there's never been a speaker chip or a fan chip. These are SMT reflowable, mounted, automated pick and place, reflowable onto printed circuit boards. So highly scalable.
Okay. Now, are these going to be some standard components that I can simply start designing into my system, or are they all custom?
They are standard components for the majority of customers. We do work with a select few large customers who want their own special thing, and on certain bases we do custom chips for certain customers and certain opportunities. But in general, we do have a standard product list that serves most customers.
Okay. Well, primarily on the thermal side, designing a system, figuring out the airflow and so on, it's going to require some thermal modeling. Do you have models for your devices to incorporate into these
Absolutely.
tools?
So we've got thermal engineers on staff that model our device, They model it in systems, be it smartphone, SSD, optical transceiver. We do the preliminary modeling to confirm that we can contribute and be a benefit to the overall system. We basically set up a secure data room for all of our customers. They have access to all those models to start their own system designs, and then we support them through the process. This is a new type of air mover, a new type of cooling device, and sometimes it requires some little assistance to get them started to understand how to best use this product.
Okay. Now, we've talked about some applications in general, but are there anything unique that people may not have thought of that they could utilize this with?
Certainly, I mean, we're discovering new applications every day. Beyond the ones I've just mentioned, some are looking at novel applications in headphones. How do I, if I'm a gamer and I've got a long gaming session, I've got condensation or humidity building up where it's causing discomfort. If I could just move a little bit of air in that headphone, it's going to extend the comfort and keep my ears dry and keep me enjoying my game.
Oh.
But we're seeing medical applications, automotive applications. We're discovering new things every day.
Well, excellent. This has been very fascinating. I'm looking forward to seeing some of these things in action.